Okay, the first kind of problem we're doing is just solving simple equations. They just have one variable and there's nothing, not like x squared or multiple different variables. We only have one kind of variable, and that's x's. So the first thing we're going to do is get rid of these parentheses, and we're going to do that by using distributive property. So we're taking this 3 and we're multiplying it by the x first to get 3x, and then we'll take this 3 and multiply it by the 2. 3 times 2 is 6, and we know it's plus 6 because this is a positive 2. So 3 times a positive 2 is going to be a positive 6. And we go over here and we have 2 times x, and it's positive 2 times a positive x, so it's plus 2x. And then we have a positive 2 times a negative 4. Remember, we're distributing this. So a positive 2 times negative 4 is negative 8. And then we still have plus 1 equals negative 26. So then the next thing we're going to do is combine like terms. So you can see we have just plain numbers, and we also have x's. Remember, the number in front of a variable, so the number in front of these x's are called coefficients. So here we have 3 x's and we have a positive 2 x's. We can combine those to make 5x, because literally if I had 3 x's here and then I added 2 more x's, I have 5 x's. So when you see 3x plus 2x, think of it that way. You add them and you have 5 x's. And then we have a 6 and a negative 8, which those would combine to be a negative 2, but then we have plus 1. So negative 2 plus 1 would be negative 1. And that's everything on this side. And then we still have equals negative 26. Okay. The easy way to solve these is to try to get all of your x's on one side and all your numbers on the other side. So now I've got my x's here, but I have a number, just a plain number here, and plain numbers on the other side. So I want to move this over here. So the way to get rid of a negative 1 is to add 1. Whatever you do to one side, make sure you also do to the other side of the equation. So now I have 5x minus 1 plus 1. Those are going to cancel out and just leave me with 5x. And then I have equals. Then I had negative 26, but I added 1. So now it's negative 25. So 5x equals negative 25. I just want to know what 1x is, though. So I'm going to divide this by 5, and I'm going to divide this by 5. So 5x divided by 5 is going to just equal x, and negative 25 divided by 5 is going to be negative 5. So x equals negative 5. What I should be able to do with this is just substitute negative 5 for x in this original equation. So let's try that. And when we substitute a negative 5 in for these x's here, we should end up with negative 26. So if this was a negative 5, we would have 3 times negative 5 plus 2 plus 2 times negative 5 minus 4 plus 1 equals negative 26. And then if I combine things, I know that negative 5 plus 2 would be negative 3, but negative 3 times 3 would be negative 9. And then here I would have negative 5 minus 4, that's negative 9, but times 2, that's negative 18. And then plus 1 equals negative 26. Well, what is a negative 9 minus 18? That's going to be negative 27, but plus 1, negative 27 plus 1 is negative 26. And that's what we were hoping it would be. So that means we solved this equation properly. Okay, we're going to do one more of these equations where we just have one kind of variable in it. We're going to start with distributive property here. We're going to take 3 times 2x. That's going to be 6x. And we're going to take 3 times 1, so plus 3. And then we have equals. Then we have 5 times x, which is 5x, and then plus 5 times a positive 2 is 10, and then minus 2. Okay, now we have x's on this side and x's on this side. We really would like all of our x's over here, so I'm going to start by subtracting 5x from each side. Okay, 6x minus 5x is 1x. I still have plus 3. Bring down my equal sign. 5x minus 5x, nothing, that cancels out. And then I have plus 10 minus 2. Well, a positive 10 and a negative 2 make a positive 8. So I know that x plus 3 equals 8. So minus 3 minus 3, that tells me that x equals 5. If I plugged that back in my original equation, if this was a 5, I would have 2 times 5, which is 10, plus 1 is 11. 11 times 3 is 33. And remember, we figured out that x was 5, so let's plug it in and check it over here too. 5 plus 2, that would make 7, times 5 would be 35, but minus 2 would be 33. And since 33 equals 33, that means that we did the problem right. Next, I want you to copy this problem down on your paper, and I want you to solve it on your own. Remember, you're just going to start by taking 7 times x and 7 times negative 4, and then adding 8 times x and whatever 8 times 2 is, and then equals, and you're going to have 3 times x plus 3 times 3, and then plus 3. So you're going to end up with some x's and numbers here, some x's and numbers here. Then I want you to combine like terms, simplify it, and then I want you to try and get all of your x's on the left side of the equation and your number over here, and then I want you to tell me what x equals at the end. Okay, the other equations that we just finished with were linear equations because they were only x to the first power. So if we get into x's to the second power, that's going to be a quadratic equation. And they're going to, if we graph them, they're going to be parabolas. But if we have an equation that just has x's to the first power, like this one, it's just going to be a line. If it's got an x and a y in it, it's still just going to be linear because our x's are just to the first power. But when we have x's and y's in an equation, a common type of problem that we do with those is rearranging them, putting them in slope-intercept form, and then graphing them. And that is what we're going to do with this one. Remember, slope-intercept form is y equals mx plus b. Remember that the m, or whatever the number is in front of the x, will tell you the slope of the line, whether it is a positive slope or a negative slope, and it'll tell you how steep that line is. And then remember the b, or just the plain number, is going to be the y-intercept, and that's where our line is going to cross the y-axis. And remember, when you're looking at a graph, this is the x-axis and this is the y-axis. So we are going to work on this equation. We're going to work on rearranging it so that it looks like this, so that we only have y's on the left side and that our x's and our numbers are on the right side. And once we get it in slope-intercept form, we're going to graph it. So I see here that my x's are on the left side of the equation, and I really want them over here. So I'm going to start by adding 18x to each side. And so this and this are going to cancel out, and I'm going to be left with 6y over here. And over here I'm going to have a 6 plus an 18x. I really want my equation to look like this, though. I want my x's before my numbers. So I'm going to put my 18x first, and then I'm going to have plus 6 because this 6 is a positive 6. There's no negative sign in front of it, so then we know it's positive. So I'm going to put plus 6. Okay, now I know that 6y equals 18x plus 6, but to be in slope-intercept form, I need to know what just y is. So if I have it right now at 6y, and I want it to be y, what can I do? I can divide it by 6. So I'm going to divide this by 6. When I do that, though, I need to divide the other side by 6 also. You can either do it like this, divide the whole thing by 6, but it is easier, especially on a slope-intercept problem, to just divide each individual term by 6. So now we're going to simplify. What is 6y divided by 6? That is just y. What's 18x divided by 6? Well, 18 divided by 6 is 3, so that leaves us with 3x. And then we have plus 6 divided by 6. Well, 6 over 6 is 1. So this is my equation. It is the same exact equation as this, it's just simplified. And now it's simplified and it's also in slope-intercept form. And remember, the reason we call it slope-intercept form is this is the slope of the line I'm going to graph, and this is the y-intercept. So when I'm graphing it, that's the first thing I'm going to do, is I'm going to graph my y-intercept. And that's 1. That means my line that I'm drawing here is going to cross the y-axis right here at 1. And then I know where to put my next point based on the slope. And you always want to think of your slope as a fraction. 3 is the same as 3 over 1. And the top number, your numerator, is going to be your rise. Your denominator is going to be the run. So from this point, I'm going to rise 3 and run 1. That means I'm going to go up 1, 2, 3. I'm going to go over 1. So from here to here is a slope of 3. It goes up 3 over 1. And I'm going to do that again. 1, 2, 3, and over 1. And you can always do the opposite. You can go down 3, 1, 2, 3, and back 1. And all of those points should make a line. Since it's a line, because this could go on and on forever, you always want to make sure and put your arrows at the end. All right, so we were able to take this equation that was not simplified or in slope-intercept form. We were able to work on rearranging it, get it down to slope-intercept form, and then make it so that it's just the y, not 6y. And then we were able to look at this and know that that's our slope and that's our y-intercept. Think of your slope as a fraction, rise over run, graph your y-intercept, and then graph your other points based off of your rise over run. Okay, we're going to do another one. I'm going to leave y equals mx plus b up there. That is something that you should have memorized, and you should be able to just immediately know what slope-intercept form looks like on an equation. Okay, we're going to start simplifying and rearranging this next equation. So this one's got a lot of problems. Our number is on the left, we need it on the right. Our x's are on the left, we need it on the right. But our y's are on the right, and we need them on the left. I would start, let's just start by getting our x's over on this side. So let's just subtract 8x from each side. Okay, so that's going to leave me with 4, and then our x's are going to cancel out. And then I'm going to have negative 4y minus 8x on that side. Okay, x's are on the correct side now, but the y's should be over here. So let's move it by adding 4y to each side. Okay, when I do that, I'm going to have 4y plus 4 equals, and these canceled out, I just have negative 8x. Okay. So our y's are in the right spot, but this number needs to go over here. Our x's are in the right spot. So let's move this over here. Right now it's a positive 4. To get rid of it, I'm going to subtract 4 from both sides. So I'm going to have 4y, and these are going to cancel out, equals negative 8x minus 4. Okay, it is all in the right order now. I've got y's equal x's and numbers. Y's equal x's and then our plain numbers. The only thing is that it's telling me what 4y equals, and I want it to say what just y equals. So I'm going to divide everything here by a 4, because 4y divided by 4 is going to give me just a y. And then negative 8 divided by 4, that's actually going to be negative 2, and then it's x minus, and then minus 4 divided by 4 is going to be the same as a negative 1. And think of this as a negative 4, but I'm dividing everything by 4, so that gives me a negative 1. So this is my equation put into slope-intercept form. Y equals mx plus b. This minus 1 is my y-intercept. So when I'm looking at my graph, negative 1 on the y-axis would be right here. And then my slope of my line is negative 2. And remember, you can think of that as a fraction. It's negative 2 over 1. That means it's going to go down 2 over 1. From this point, it's going down 2 over 1, down 2 over 1. And remember, you can always do it in the opposite direction. You can go up 2, back 1. And then we can connect those. And that is our line. It goes on and on forever, so we put arrows. Good job. Now I want you to try one on your own. On your paper, I want you to write y equals mx plus b. And that is your goal, to rearrange this equation and get it in that order where you have y equals your x's and then your numbers. So this one, we can see that the 9 is in the wrong place. So you're going to have to move that to the other side. And then you're going to end up with an equation that says 3y equals something something. And you want 1y. So then you're going to go through and divide everything by 3. And then I want you to graph it. I want you to start by plotting the point that is your y-intercept. And then I want you to figure out what your slope is. I want you to turn your slope into a fraction. And whatever the top number is of your fraction is your rise. You're going up that many points from your y-intercept. And then the denominator of your fraction is the run. And then you're going to go over that many points from your y-intercept. And then I want you to put at least 3 or 4 points, and then I want you to connect them and make them a line. Next, we are going to talk just a little bit about circles. We are going to review how to find the area and the circumference of a circle if we are given the radius. So the area of a circle is pi r squared. The circumference of a circle is 2 pi r. So when you're given the radius of a circle, you can easily find either one of those, area or circumference, just by plugging the length of the radius in for r in these equations. So the first one we're going to do is we're going to find the area of a circle with a radius of 3. So I know the formula for area of a circle is area equals pi times the radius squared. And the radius in this example is 3. So I'm going to say times 3 squared. Okay. Some problems you can just leave pi as pi. Some problems will tell you to use 3.14 for pi, and some problems will want you to use more decimal places than just 3.14. We're going to use just pi and 3.14 on this problem. So area equals 3 squared is 9. You want your number in front of the pi symbol times pi. So pi times 3 squared is the same thing as 9 times pi, or you could write it as 9 pi. And then I want you to also write your answers excuse me, using 3.14 for pi. So I'm going to also say area equals 3.14 times 9. And when we multiply 3.14 times 9, 9 times 4 is 36. I put my 6 here. I carry my 3. 9 times 1 is 9 plus 3. is 12. So my 2 here, and carry my 1. 9 times 3 is 27. Plus 1 more is 28. Go over 2 spaces for your decimal. So we know that the area of a circle with a radius of 3 is 28 and 26 hundredths. The next problem that we're going to do is still a circle with a radius of 3, but this time we're going to find the circumference. All you do is think of your formula for circumference, which is circumference equals 2 times pi times r, but then we are substituting a 3 in for the radius. And then you just simplify. The circumference equals 2 times 3 is 6 times pi, so 6 pi. And then again, I want you to go ahead and substitute 3.14 for pi. So the circumference equals 3.14 times 6. 6 times 4 is 24. 6 times 1 is 6, 7, 8. And 6 times 3 is 18. And put your decimal point. So we know the circumference of a circle with a radius of 3 is 18 and 84 hundredths. So the last thing you are going to do in this lesson is you're going to work a problem on your own where you're going to find the area and the circumference of a circle. And here's your problem. You're going to find the area and circumference of a circle with a radius of 4. So I want you to just copy down each formula and plug 4 in for your radius. Remember, on the area, you're going to have to square 4. So you're going to take 4 times pi. And for the circumference, you're going to take 2 times pi times 4. Then I want you to simplify those answers, and I want you to use 3.14 for pi.